So in this video, we will discuss that if there is any differential equation given first order and higher degree in the form of x equals to any function of yp, then how to solve those differential equation. It's known as solvable for x. Okay. So equation solvable for x. If the given differential equation, we can modify that differential equation in the form of x equals to any function of yp, then we can differentiate this differential equation with respect to y. Then it will be dx dy equals to any function of yp and b dy. Okay, and it will be a basically this equation too. It will be first order and first degree. Okay, then we have to solve this differential equation, and suppose the solution is in the form of phi of ypc. Then we have to eliminate this p. We have to eliminate p from the equation 1 and 3. Okay, so in this way we will get the general solution of the differential equation. Now try to understand this method with an example. Okay, so suppose the given differential equation is y square log y equals to xyp plus p square. Okay, so if I want to apply solvable for x, we have to represent this equation, or you have to modify this equation in the form of x equals to any function of yp. Okay, then we can apply this method. Otherwise, we have to go for another method. Okay, so we can write the given differential equation in the form of x equals to y log y divided by p minus p by y. Now, if we differentiate this equation with respect to y, it will be dx dy equals to, it's basically u by v rules. So it will be p square p into 1 plus log y minus y log y dp dy. And if I differentiate the last term, means this term, with respect to y, it will be y square y into dp dy minus p. Okay, now we have to simplify this equation. So it will be 1 by p in left hand side, and the right hand side it will be 1 by p plus 1 by p log of y minus y by p square log of y dp dy minus 1 by y dp dy plus p by y square. Okay, and so we can write this differential equation in this form, 1 by dp dy. So from this two term, from this term and this term, if I take 1 by y dp dy common, it will be 1 plus y square by p square log of y. Okay, and from it will be actually cancel out, and from this term and this term, if we take minus p by y square common, it will be 1 plus y square by p square log of y. Okay, so this equation become 1 by y dp dy minus p by y square into 1 plus y square by p square log of y equals to 0. Okay, so we can discard this part, and from this equation we can write dp dy equals to p by y. So using separation method, we can write this equation log of p equals to log of y plus log c. So after integrating this, after separating, means we can write this equation in the form of this equals to dy by y. And if we integrate both sides, so it will be this, and from this equation we can write p equals to cy. Okay, now from this equation, if I put the value of p in the given equation, so it will be log of y equals to cx plus c square, which is our required solution of the given differential equation. Okay, now pause this video and try to find the solution of this. Okay, so now let me explain this method. So in this equation, if you first look at the solution, look, in each and every book you can find the solution. The solution is not important here. First try to understand that in which way we can solve this equation. Suppose in previous two video we learned how to find solution if the equation is in the form of, we can write the equation in a linear factorize. We can factorize the given equation in this form. Then how to solve this? So for this equation, can I write the given equation in this form? So answer is no, definitely no. Now, in the second video in this chapter, we learned if the given differential equation is in the form of y equals to any function of xp, then how to find the general solution. Can I write this equation in this form? Again, answer is no. But we can write this equation in the form of x equals to any function of yt. So for this differential equation, we have to apply solvable for x, not any other method. Okay. Now, go to the solution. So we can modify the given differential equation in the form of x equals to tan inverse p plus p by 1 plus p square. Okay, this is our given equation. So I think the given equation in the form of this. So if we differentiate this equation with respect to y, so it will be 1 by p equals to 1 by 1 plus p square dp dy. It's basically a derivative of tan inverse p. And the last term, it will be 1 by p square of whole square. And it will be 1 plus p square minus 2p into p dp dy. Okay, so now if you simplify this, it will be 1 by p 2 by 1 plus p square whole square dp dy. Okay, so using separation method, we can write this differential equation in the form of dy equals to 2p 1 plus p square whole square dp. Okay, and if we integrate this in both sides, it will be y equals to c minus 1 by 1 plus p square. Okay, I think the method is simple. So just you have to take the substitution here. You can solve this with yourself. Let me give you a hint that if I take 1 plus p square equals to any variable like u, so it will be 2p dp equals to du. Okay, so using this substitution, you can easily find the solution. Okay, so from here we get the value of y. So we can find the value of p from this equation. There is one way we can find the general solution. We can find the value of p just modifying this equation. There is another way to write the solution. Just simply write the value of y. So y is c minus 1 by 1 plus p square. And if you write the given equation with this equation, so from this two equation together is known as general solution. If suppose for any problem you are unable to eliminate p, so you can write both of these two equation as a general solution of the given equation. Otherwise, you can find the value of p from this equation and you have to put the value of p in the given equation. So in this way, you can find the general solution. Okay. So both of these two methods are correct. Okay. Now pause this video again and try to find the general solution of this equation. Okay. Okay, so let me explain this method. Again, we can say that the given equation, we can write the given equation in the form of x equals to any function of y p. Okay, so we can write the given equation as x equals to y by 2p minus 2y by 2. This is our given equation. Now if we differentiate this equation with respect to y, we get 1 by p, this is dx, dy equals to 1 by p square, 1 by 2p minus y by 2p square dp dy minus p by 2 minus y by 2 dp dy. Okay, and we just simplify this. We can write this in the form of 1 by p, 1 by 2p minus y by 2p square dp dy minus p by 2 minus y by 2 dp dy. Okay, now we can write the given equation in this form and again in this form. Okay, now from this equation, the in the second term there is dp dy, so it will this equation, this part will gives us the solution. Okay, this part. Okay, we can discard this part. Okay, so this equation can be written in the form of dy by y plus dp by p equals to 0. So from this equation, we have to find the value of p. I think it's very easy to solve this. So the value of p equals to c by y. Okay. So now we know the value of p. P is c by y. Now in the given equation, it was, let me check the equation. The given equation was y equals to px, y equals to, so we can put the value of p here. So it will be 2x into c by y plus y into c square by y square. Okay. So therefore it will be 2cx by y plus c square by y square. You can simplify this a little bit more. So it will be y cube equals to 2c x y plus c square, which is our required solution. So I hope the method is it's okay. You can use this method to find the solution of this type of problem. Okay. Now there are 5 problems. I think I already discussed this one, also this one, and another one. So let me discuss another problem here. So let me take the last one, this one. Okay. Problem number 5, p square plus y minus x equals to 0. Okay. So how to think? Because in examination, they will not mention that which method you have to apply. Okay. So I'm thinking that can I write this equation in this form? Can I write this equation in this form? Means can I factorize this in terms of t? So answer is no. We can write this equation in the form of this, any function of xp. So we can, for this problem, we can apply this method. But in this video, since we are discussing how to apply solvable for x, so let me rewrite the given equation in the form of x equals to y plus p square. Okay. So I think is this format is basically solvable for x. Now, if we differentiate this equation, if we differentiate the equation with respect to y, then we get 1 by p, 1 by p equals to 1 plus 2p b dy. Okay. Now we can write this minus so 1 by p, so it will be 1 by 1 minus p, so we can write p minus 1 divided by p, since we are taking minus 1 common. So okay, and the right hand side it will be 2p dp dy. Okay, now it's become the first order first degree in p, so we can write this equation 2p square divided by p minus 1 dp equals to minus dy. Okay. Now, so we just have to integrate in both sides. So it will be integration to p square divided by p minus 1 dp minus integration dy plus c. Okay. So it will be now. So we can write this in the form of p square minus 1 plus 1. So ultimately it will be p square. Okay. Divided by p minus 1 dp minus y plus c. Okay. So in next step, we can write this p plus 1 because p square minus 1 is p plus 1 p minus into p minus 1. So it will be cancelled out. So it will be p plus 1 dp and the next term it will be 2 integration 1 by p minus 1 dp equals to minus y plus c. Okay. Now it's very easy to solve this. So it will be 2 into p square by 2 plus p and it will be 2 log of p minus 1 equals to c minus y. Okay. So from this equation we can write y equals to, so this is the value of y. So basically from this equation, from this solution, we have to find the value of p and we have to put the value of p in the given equation. That will be our required solution. But for this problem, it will be little bit difficult to find the value of p in terms of y and constant. So what we can do, we can just write both of these two equations like this equation. So this is our required solution of the given equation 1. Okay. If possible, you can find the value of p, but for me, it is a little bit difficult to find the value of p. So that's why I'm writing both of these two equations in this format. So both of these two equations togetherly is known as required solution of the given differential equation. Okay.